1.4 Parametric equations. So before we dive into talking about parametric equations and how to use them, the first thing I want to do is dive into how to set up your calculator, because it is slightly different. So when looking at your calculator, you're going to want to go ahead and go to Mode to bring up this window. And then you're going to want to go ahead and change it from function. So go down to function and switch it over to parametric. You push enter to go ahead and make that switch. And that's going to be important because it changes how the calculator operates. So when you do y equals, you're going to get x and y values. So let's first remember back to what a relation is. Not a function, but a relation. So a relation is a set of ordered pairs which are usually x comma y. If x and y are both functions of a third variable t for time, we call t a parameter, and the ordered pairs become x of t and y of t. So x and y are determined by what t is. So in example 1, we're going to describe the graph where x equals square root of t and y equals t when t is greater than or equal to 0. And so the first way we're going to do that is we're going to go ahead and just plot all the points. So we're going to plug numbers 0 and larger in for t and see what we get. So when you plug it in here, you get x of 0 is the square root of 0, which is just 0. You plug 1 in, and the square root of 1 is just 1. Square root of 4 is 2, and so on. And then for the y value, you're going to plug it into the y function. So you get 0, y of 1 is 1. So you get 4, 9, and 16. So then the next thing that we do is those are going to be our ordered pairs. So it's 0, 0. It's going to be 1, 1, 2, 4, 3, 9, and 4, 16. Now already that starts to give us a shape of what this thing should be. So if I were to plot all these points, I get 0, 0, 1, 1, 2, 4, 3, 9, and 4, 16. And we can see how that starts to take the shape of a parabola. So what I want to teach you how to do now is actually do that on your calculator. So I want to teach you how to take something like this and throw it into your calculator. So where it says x sub 1, we're going to type in square root of t, because x of t is the square root of t. And to get t, you're just going to click your variable button. And because we're in parametric, it changes it to a t instead of an x. And this one was just t. Then you push enter. And then for window, for t max, we just need to make it something big. So 6 is fine. Sometimes you use 10, but just anything large is fine. And then for x min, I like to make my min -10 and my max 10. And same for the y. That's kind of my default. You can play with the windows if you want. Another part of parametric functions that are very important is understanding how they graph in the order that it goes. As t increased, the graph moved in this motion. So it's very important that we write out how it acts. So the graph goes to the right and up, right? Because sometimes when t increases, it could go the other way. Now what we want to be able to do is go ahead and write that function without t. And this is called using the Cartesian coordinates. Cartesian is our typical xy. And the technique that we're going to do is we're going to solve for t. So I have my two equations, which is x equals square root of t and y equals t. So now all we need to do is get to t by itself over here. So I square both sides. And I get t equals x squared. And so I'm going to replace this t with x squared. and it becomes y equals x squared, where x is greater than or equal to 0 because of this constraint here, because x is always positive. So what I want you to do here is get rid of the t and solve for the Cartesian equation. All right, so here we go. So we have x equals 2t. So I'm going to get t by itself. So t is equal to x over 2. Then I replace t with x over 2. So this is 4 x squared over 4. So it's y is equal to x squared. So notice that my equations were a little different when in parameter form. However, we get it's very similar here. Now, in order to get the restriction, you need to plug in t values. So you always start with t equals 0. So then for x, when t equals 0 is 0. So we get x is greater than or equal to 0. Because x is only going to get larger from there.